This video is going to demonstrate building the five different fitness functions using a set of observations and a set of forecasts. Now, on the exam, I'll provide both of these to you and expect you to calculate the deviations, absolute deviations, and squared deviations. The difference between 2 and 2, of course, is 0. 3 minus 4 is -1. 6 minus 6 is 0. 7 minus 8 is -1. 8 minus 10 is -2. And 13 minus 12 is 1. Absolute deviations: 0, 1, 0, 1, 2, and 1. And squared deviations: 0, 1, 0, 1, 4, and 1. Now, the next thing we need to do, once we've calculated the deviations, the absolute deviations and the squared deviations, is we need to come up with column sums. Now, I am going to go ahead and use the sum function to calculate the sum of observations as well as the sum of the three types of deviations. The sum of the deviations, absolute deviations, and squared deviations. Final thing I need to do is come up with a count. How many observations am I dealing with? 6. So, the cumulative error is nothing more than the sum of the deviation column. And the average error is going to be -3 divided by 6, the count. Mean absolute deviation, let's go ahead and calculate that one first. It is going to be the sum of that column, the sum of the absolute deviations, divided by the count. And the mean absolute percent deviation is the sum of that column divided by the sum of the observations, 39. Mean squared error is the sum of the squared deviations divided by the count. So, when you go about doing this, seeing this table on the exam, you should be able to calculate those deviations very straightforward manner. You do need to practice this, doing this by hand. This video will cover the last page of the forecasting supplement, where we look at calculating all of the fitness functions for the Wishbone Farms dataset using array functions in Excel, or array formulas in Excel. The difference between a regular formula and an array formula in Excel is that the array formula operates over a range of data, whereas a regular formula is typically going to operate over a single cell. And we're going to use these array formulas because they bypass the whole set of having to calculate independent or individual deviations, square those deviations, add them up, take the average, and so forth. We're going to begin with the mean absolute deviation. And for the mean absolute deviation, we want to take the difference between the observed and the forecast, take the absolute value of this, and then divide by the count. Now, what makes an array formula different is, again, the observed and the forecast are ranges. They're not individual cells. If we were doing an individual cell, this would be a very straightforward formula. Now, the array formula is going to be distinguished by the brackets that surround the formula. Notice that the formula is surrounded by curly braces. This is not something that you type into the formula. You go ahead and write the formula itself without the curly braces. But instead of hitting enter to complete the formula, you will hold the Control-Shift character or keys down as you hit enter. And that will add the curly braces to the formula and let Excel know that this is not a regular formula, this is an array formula. So let's take a look at this. The first formula that we're going to use is the sum of the absolute value of observed minus expected, or observed minus forecast, divided by the count of the observed. In Excel, I have gone ahead and defined ranges. We've got the observed range, and we have the expected range, the forecast. So, for the Excel formula for mean absolute deviation, it is equal to the sum of the absolute value of observed minus expected, divided by the count of observed. So this is our complete formula. Notice that Excel has identified the ranges that we're dealing with. And to complete this, I'm going to hold the Control-Shift down as I hit Enter. And that gives me a mean absolute deviation of 0.2807. And if we look up here in the formula, we'll see that Excel has added those curly braces. The second formula we want to calculate is the mean absolute percent deviation. Here, instead of dividing by the count of the observed, we're going to divide by the sum of the observed. Equal the sum of the absolute value of observed minus expected, divided by sum of observed. And holding Control-Shift, we hit Enter, and we get a mean absolute percent deviation of 0.022, or just over 2% average deviation. Now the third one we want to calculate is the cumulative error, E. For the cumulative error, we're simply going to sum observed minus forecast. No absolute value. Remember, this cumulative error will have a sign. And of course, average error, we're going to take the cumulative error and divide by the count. So nothing more than the sum of observed minus expected. Now, when we hit Control-Shift and Enter, we get a very small value, 4.3 times 10 to the negative 12, which is effectively 0. Now, you might wonder, how did this forecast become so accurate? Well, remember that this forecast is based on a regression model, and the regression model is going to run the regression line right up the center of the data. And when you do that and calculate the residuals, if you add all the residuals together around a regression model, you end up with 0. So it's not unexpected that a model that is based on a regression is going to have a cumulative error as well as an average error of effectively 0. So let's go ahead and calculate the average error. Equal sum of observed minus expected divided by count of observed. Control-Shift, Enter. And of course, if we go ahead and rescale these so that we have just 3 decimal places showing, error and cumulative error now and average error look like they are 0. The final function that we're going to calculate is the mean squared error. Now, the mean squared error is not going to use an array function. Excel provides a function for us, the sum xmy2 function, sum of x minus y squared. And for the arguments for that function, observed and forecast, the 2 ranges, what that function is going to do is cell by cell within the ranges compare the observed to the forecast, calculate the deviation, and square that deviation. So that gives us a sum of squared errors. We divide that sum of squared errors by the count to get the mean squared error. Equals sum xmy2 observed. What did we say? Forecast. Expected. Forgot the names I'm using here. Divided by count of observed. And again, this is a regular Excel function. It is not an array function, so we're simply going to hit Enter. And that gives us a mean squared error of 0.109, which is a pretty good mean squared error for a data set. Now once again, I am not going to test you using the array formulas. What I would like you to do is be able to calculate these deviations by hand using the table that I've provided for you as fitness functions in WebCT.